Hello friends, how are you? Hope you are doing well and you are just preparing your syllabus and your ideas for your well-being. So दोस्तों, इस चैनल में मेरा सभी न्यू फॉलोअर्स, न्यू विजिटर्स, सब्सक्राइबर and also who are just थिंकिंग टू सब्सक्राइब माई चैनल्स, सभी का मेरे इस चैनल पे स्वागत है। दोस्तों, आज मैं एक बहुत ही अच्छा वीडियो आपके लिए मैं लाया हूं। यह है काफी काम आने वाली वीडियो है, जिसमें मैं आपको बताने वाला हूं कि व्हाट इज रिडंडेंट फ्रेम्स। रिडंडेंट मीन्स व्हाट इज स्टैटिकली इनडिटरमिनेट फ्रेम्स। व्हाट आर द डिफरेंस बिटवीन स्टैटिकली इनडिटरमिनेट एंड स्टैटिकली determinate structures. I will also show you some examples in statically indeterminate structures. Next, you will find in this video that what are the types of statically indeterminate structures. I will also bring you in the next video the degree, how to know the degree of statically indeterminate structures for various types of portal frames, trusses, beams. Methods are not similar to know the degree of statically indeterminacy. There are different methods applied to know the degree of statically indeterminacy. So please, you are requested to like and subscribe my YouTube channel so that whenever I post my videos, you will be the first person to get it. तो दोस्तों, मैं जस्ट ब्रीफ में आपको बताना चाहता हूं कि जैसे हमने अभी पिछले सेशन में मैंने पढ़ा है, मेरे 33 वीडियो आ गए हैं ऑलरेडी। मैंने उस वीडियो में देखा है कि ये दो बीम है दोस्तों, ये बीम है। दिस इज सिंपली सपोर्टेड ओवरहैंग विद टू सपोर्ट्स। तो ये दोस्त, जहां पर सपोर्ट रिएक्शंस, देयर आर ओनली टू सपोर्ट रिएक्शंस। दिस टाइप्स ऑफ और सिंपल कैंटिलीवर बीम। दिस इज कैंटिलीवर, प्लीज सी दिस। तो दिस टाइप्स ऑफ स्ट्रक्चर इज कॉल्ड डिटरमिनेट स्ट्रक्चर्स, वेयर यू कैन अप्लाई ओनली 3 numbers of equation with equilibrium to solve it. Summation of vertical forces is 0, where upward and downward forces are equated, and we take one section and bending moment at that section, either left side or right side, we just calculate it to find the support reactions. When you get support reactions, then you draw shear force, bending moment, etc. But friends, when the support reactions is more than 2, what will happen? Suppose these 2 support reactions, and I am again giving one additional support reaction. Suppose there are 2, and here is the, you see, here is the just 3 support. There are 3 support reactions. Support reactions. Then, friend, due to these 3 support reactions on the beam, it is not ordinary structures. It will become the statically indeterminate structures. Since numbers of unknown equations are more than numbers of known equation 3, so we will apply the other methods to solve the structures for bending moment and shear forces.
दोस्तों, बिना समय गवाए हम आगे बढ़ते हैं।
Hello friends, start this video. Then what is redundant frames? These are the structures which are unable to be analyzed by the condition of equilibrium. So please, of all the vertical forces is equal to 0. This is number 1. And number 2, summation of all the horizontal forces is 0. And third, summation of all the moment at a point at any section of a beam is 0. This is 0, and like a moment of all the forces at a section is 0. These are the three equilibrium equations available universally for, remember, two-dimensional static equilibrium. So a static word and two-dimensional word is important here, and all my followers and YouTube channels subscriber are requested to remember this. Now please find what are the difference of statically determined and indeterminate structures.
So friend, just start the video without loss of time. मेरे सभी दोस्तों से, मेरे सभी नए विजिटर से आई रिक्वेस्ट है कि वे मेरे इस चैनल को ज़रूर सब्सक्राइब करें और अपना कमेंट्स दें. Please see the example of statically indeterminate structures.
There are two-dimensional structure. For examples, if you take the beam like this, and this is the support. There are three supports, suppose B1, B2 and B3, and there are more than or one or two loads, W1, say W2 and W3. This is a continuous beam, and this is a statically indeterminate structures. This is beam, continuous beam, continuous beam. I am just giving some examples, and please follow my videos for later on. I will discuss the degree of the structure, how the redundancy, how the indeterminacy of the frame is calculated. So again, I am putting one examples. Just please see here. So suppose this is this is a hinge. There is hinge, and here is W1, and this is W2. It is a two hinge arc. Then you will find that here will be, due to hinge, there is one force, one reactions, and see here one reactions. These are the reactions developed here for two hinge arc. These are the example of statically indeterminate structures. And if you take one fixed beam for the, this is the normal cantilever beam with point load at the end, and if you just put one support here, then this is called propped cantilever, and this become a statically indeterminate structures. Again, if you take, I am giving one examples of this called, see here, this called truss. Here, just rough sketch to understand the things, and put here. This is the roller supports, and this is the roller support, and this is the hinge supports, and let's put here W, and this is just, this point is O. Then this is also indeterminate structure. This is the example of truss. If you take one example of portal frames, I am giving you one simple portal frames. This is called the portal frames, W, and this is hinge, and this is on the rollers,
So this is hinged. So it again become, there is one moments, this one and this one. So again this is a portal frames, simple portal frame. So these are the friends, the example of a continuous beam, 2 hinge arc, this is truss, and this is prop cantilever, and this is portal frame. These are some of the examples of two-dimensional statically indeterminate structures.
Now please find what are the difference of statically determinate and indeterminate structures. So please watch this.
So please see here, there are some important difference between statically determinate and statically indeterminate structures. First one is, please see, first one is the condition of equilibrium are sufficient for fully analysis of the structures. There are 3 conditions of equilibrium, universal equations. There are 3 numbers I have already discussed just now. With the help of 3 equations, you can solve the statically determinate structures. But for the statically indeterminate structures, this condition, 3 conditions are not sufficient to getting analysis, and you have to create more equations. ज़्यादा equations आपको अपने से बनाने पड़ेंगे to solve the depending upon the उसकी इंडिटरमिनेसी डिग्री क्या है. जितने ज़्यादा डिग्री होंगे उतने ज़्यादा इक्वेशन आपको फॉर्म करने पड़ेंगे स्टैटिकली इनडिटरमिनेट स्ट्रक्चर को सॉल्व करने के लिए. नाउ फ्रेंड्स, और नेक्स्ट द बीएम एट अ सेक्शन और फोर्स इन एनी मेंबर इज इंडिपेंडेंट of materials of the component of the structures. What do you mean independent of the material of the component of the structures? For the statically determinate structures, there is only force into distance and bending. You can get the bending moment at the point. And the bending moment for the statically determinate structure does not depend on the material of the components. What is mat force? But for the bending calculation, bending moment for the statically indeterminate structures, the bending moment at a section or force in a member is depend on the material component of the structure. Materials component of the structures. Suppose a material component is steel and another component is brass and another component mild steel. There are 3 kinds of material in a frame, in a structures. Then the bending moment at the particular sections or particular members will depend on the material of the components, what is made of the materials for is made of in the statically indeterminate structures to calculate the bending moment at a section or force in the members. But this is not for the statically determinate structure. The bending moment is not independent of the materials of the component of the structure. Independent word must be here noted for the statically determinate structures. Next, for the statically determinate structure, bending moment at a section or the force is only member is independent of the cross section, independent of the cross section of the area of the components. The bending moment is independent of the cross section area of the component for the statically determinate structure. But when you calculate the bending moment at section
or the force in a member in the statically indeterminate structure, then the bending moment or the force will depend upon the cross-section area of the components. If there is a larger cross-section area or a smaller cross-section area, this should be given weightage to finding the structure analysis or reactions for the statically indeterminate structures. But in the statically determinate structure, all the members are independent of the cross-section area of the component. So two are the difference. Please remember. Next, no stresses are caused due to temperature variation. If temperature is varying at a place, suppose 40 degree, 50 degree or 30 degree, then the bending moment will not cause any stress due to changes in the temperature. This should be these are ignored in the statically determinate structure analysis. But for the statically indeterminate structures, the variation of temperatures will affect the stresses in the member. So these are the some of the important differences for statically indeterminate structures and statically determinate structure. This next, please watch. What are the types of indeterminacy? It is external indeterminacy and it is indeterminate structure due to internal reactions. This is called the internal indeterminate structures. So please now come to the point. What is the external indeterminate structure? Types of indeterminacy. There are two types of indeterminacy in a structures. One is called external indeterminacy and other is internal indeterminacy of the system, in the system of the. So please remember that while you are talking the statically indeterminacy of a structure, then it is two kinds. It just I have discussed. Now please remember the definitions of the external indeterminacy. What is external indeterminacy? External indeterminacy when the support reactions of a structure can be solved with the help of equilibrium equations, then it is called the external indeterminacy of the structure. Suppose you have already read, so this is the beam. Suppose this is the beam and there is only two support reactions.
Then the reaction RA and RB you can solve with the help of equilibrium equations. Okay. But when the structure like this is the continuous beam. Suppose here is W1 and here is W2, and reaction particular reaction RA, RB and RC. This is a continuous beam. This is the simply supported, and this is continuous beam. Then for this beam, since there are more than 2 support reactions, you cannot solve with the help of equilibrium equations. There are 3 equilibrium equations I have already discussed. So this kind of a structure is called external indeterminate structure. This is external indeterminate structures. Simply, please remember it. When the support reactions, there are more than 2 support reactions, then the structures become externally indeterminate structures, and you have to apply certain formula to know the analysis the beam. If you apply here RA plus RB plus RC equal to W1 plus W2, then it will be wrong. You do here, you cannot do here in this type of structure, since it is externally indeterminate structures. So it is the vital point must be remembered by all my friends. Even now I am just discussing what is the internally indeterminate structures. Internally indeterminate structures. What is this? First, see one example, then it will be clear to you. Suppose I am giving one portal frame to you like this. This is the portal frame. Okay, and here and here, this is roller. This is roller support, and due to here 1 reactions, and this is hinge support, there is 1, 2 reaction, here 3 reactions. And suppose here also a load is there, and also here is W1 there. Then 2 plus 1, total reaction is 2, here is 1 reaction. Then 2 plus 1 equal to total 3 reaction is there. And if you subtract 3 minus equilibrium equation 3, then it will become 0. Then for this simple structure portal frame, you can find the support reactions with the help of equilibrium equation, simple equilibrium equations. But due to the internal reactions developed due to the frame, due to these arms, you cannot find the other reactions inside the frame, and due to this reason, this frame become the internally indeterminate structures. I am giving another examples like this. See here, this is hinge and this is on the roller. one truss, like this, like this, like this, and just suppose like this, and here is W1, W2, and let us one horizontal force also. Then see here again, there is two reactions, here is one reaction. Due to total reaction, support reaction is 3 and equilibrium equation is 3, then 3 minus 3 0. Then you can only find the support reactions with the equation of equilibrium. But the structure is internally indeterminate structures due to the reactions exerted by internal reaction exerted by the frame members due to internal reactions exerted by the internal components of truss.